Alright, ladies and gentlemen, I'm going to walk through how to complete steps 1 and 2 for activity 4.4, but I'm not going to use the data sets given here. You will need to use those, but I'm going to be using the data set that we did in the example yesterday. So when I am showing you how to do this, the answers may not be the same, but the method will be. So let's take a look at what we need to do here. So we used Excel, we're using Google Sheets, to scatter plot of data and trend line. So we put in the data, created a scatter plot, added a linear trend line, and formatted the trend line to forecast backwards 5 units. In hours, we were forecasting forwards. We actually went more than 4 units. But as a reminder, when you're doing that, you just go to Customize, Horizontal Axis, and then you can change the minimum and maximum on the horizontal axis to forecast forwards or backwards. Then next thing it told us to do is you do not need to print your graphical model. You're just going to reference it on your computer. And then the only part on so I'm going to say step 1, say A through B, sheet. Put 0.4. Oh, made that way too big. Walls. Right, so A through D are in sheets, and then E asked me to describe the correlation. And you're going to be answering this for the runoff versus rainfall, but I'm looking at the correlation for our existing data set from here, which is right here. Now, in order to get the correlation, you will need to be looking at the R² value. I'm going to reference where you find this information as well. So if you go back to this PowerPoint, here we go. Here's the correlation coefficient. So if our R is greater than 0.8, it's going to be a strong correlation. If it's less than 0.5, it's a weak correlation. And if it's somewhere in between, it's a moderate correlation. So in order to find the R value, I'm going to take the R² value, and then I need to take the square root of both sides. So that gave me R equals 0.895. R equals 0.946. I'm going to say 0.95. Referencing back to my thing, 0.95 is greater than 0.8. And so I'm going to say which is greater than 0.8. This means therefore. So therefore, strong correlation. Referencing back to this slide here, if it were to have been R is less than 0.5, I would have said a weak correlation. If it had been R anywhere between 0.5 and 0.8, I would have said a moderate correlation, or neither strong nor weak, something like that. All right. Moving on to number 2. it says use the mathematical model, and I'm going to be using the example. You guys will need to be using the spreadsheet that you create for runoff versus rainfall up there. So rewrite the equation to trend line, and for runoff versus annual rainfall, I again am not doing runoff versus rainfall. I'm going to be doing this for sales versus time. 2. And I actually did this yesterday, but as a reminder, you're going to look at this equation right here and convert that into whichever are the appropriate variables. So for function notation, I need sales as my y-axis as a function of time equals 0.134 t, because that's my time, plus 2.03. That was pretty easy. Next, what is the domain of this function? So in math, when you're asked for domain and range, a lot of times you're going to just see on the graph like what the domain and range is, or you'll have to, but in engineering, you have to decide what domain and range makes sense. So I'm going to talk about the domain and range for mine again with the sales projections. So for my domain, which is time, anything below 0, obviously, actually anything really below 1 makes no sense, because if I said my first year is 2003, I can't go backwards from 2003, and so it has greater than 1 for sure, and so I'm going to say domain definitely greater than or equal to 1 for time, and less than or equal to, this is a judgment call, but I'm going to say, because I currently have 9 years, I don't feel comfortable projecting more than like an additional up to about 20 years, because there could be some big changes to my company in that time frame, or after that time frame, and so I'm only going to use 20 years as my range. But again, I'm sorry, as my domain. But that is, that's something that you have to decide, and it's going to be different for yours. You want to talk with your group about how to decide what is a reasonable amount of rainfall. So, is it reasonable to have no rain? Is it reasonable to have 10,000 inches of rain? Probably neither of those. So somewhere in between that. All right. So for C, it was asking me for the range. The range I calculate using the equation. So the range, you can either calculate using the equation or looking at the graph. I'm going to look at the graph because that is that's easier. So on my graph, I can see for when when my for year 1 right here, based on the trend line, the range looks like 2.2 million. So I'm going to say the range is 2.2. This is sales. And then for 20, it was 4.467, 2.7. And this is in millions of dollars. Sorry, that should be, when you do it, try to do a little neater than I just did. So that's because my range my units of the y-axis were in millions of dollars. For yours, it's going to be the amount of runoff, and it'll be a totally different graph. So just follow that same pattern for yours. You can also calculate it using this equation. If you want to do that, you would just plug in the minimum domain number for t here to find this, and then you would plug in the maximum, which is 20, to find this. And I just said 2.7, I realized. It's supposed to be 4.7. Next, we're going to look at the slope of the trend line, and then doing some estimation activities, and I'm going to do that in a separate video.